subcomponent of buffer called items, and now I can do array indexing. Okay, so in this case, let's say I want to initialize the third item, the third element of items, to a particular value of 15. And define sub invoke main. So once again, I have defined a fairly useless program, other than the purpose of illustrating the concepts. It doesn't do anything useful at all. But the concept of a queue will come back later, okay? Because it's a very, very good introduction to data structures. Now we'll go ahead and trace this program and see, what it looks like. I think most of you already have a pretty good idea of what it should look like, but let's just go ahead and visualize, this anyway. Nothing to say about the precondition. Line 10 invokes the subroutine, so it has a return line number of post. But we also have to allocate for the local variable at the same time. How many columns do you think buffer should take up this time? Nope, a little more than that. 6 columns. Okay, it takes up 6 columns because head index is 1, size is 1, and then items takes up 4. So 4 plus 1 plus 1 is 6. So it takes up 6 columns. So buffer, every time I refer to buffer, it is referring to these columns, everything up to column H from column C. But then buffer is broken up into 3 components because it is a record. The first component is called head index. It takes up just column C all by itself. The second column is size, which takes up just 1 column because size is an integer already. But the third component called items is an array. The third component takes up 4 columns all by itself. Because items is an array, we can also address the individual element. So instead of using items bracket something, I'll just use bracket 0. It is just understood that you have to add bracket 0 to items. So the first one is bracket 0, bracket 1, bracket 2, bracket 3. And that's, okay, let me just shrink all the columns so that we can see the overall picture of the structure. Okay, so if you look at buffer as one single thing, we are referring to column C to column H. If you want to address, or if you want to access head index, then it's just column C. If you want to just access size, it is column D. And then when you talk about items, it is referring to column E to column H collectively. If you want to access individual elements of items, then you have to use the bracket notation to access the individual items. And once again, we have to make sure that every single column starts with an unknown value because the entire thing is a local variable. Now we start execution on line 8, which is a single line to access a particular item. So in this case, we are using buffer, and we are going down to items and bracket 2. So we are talking about column G. Column G in this case is updated to a value of 15. Then we are done. I mean, this program doesn't really do anything other than changing one of the columns. In other words, the pseudocode, the logic doesn't make any, it's useless. It is just, how the columns are utilized, and that's the focus, at this point, is how do we use the columns to represent arrays and records and a mixture of these two concepts. And let me save the file first, make sure I save it before I get out of here. In this case, it is an array in a record. Now, there's one more thing. I know it is time already, and most of you need to prepare, dinner for tomorrow. But there's one important thing to remember. In this particular program, Q is the name of a cookie cutter. Okay, so remember this analogy too, because it will be useful, especially when you move on to an object-oriented programming class. What is a class? What is an object? in this class, at least at this point, I don't want to talk about what is a class and what is an object. I just want to talk about what is a cookie and what is a cookie cutter. A cookie is something that you can eat, right? A cookie is something that can be individual. I like this cookie better. I like this cookie better because it has more chocolate chip than the other cookie. Does it make sense? Okay, so cookies are individual things, and they take up resources too. Okay, every single cookie takes up cookie dough. Okay, and cookie dough is basically columns in our trace representation. So cookies are stuff that will take up columns in our cases. Okay. But how do you shape the cookie dough into things that you can actually use? You use a cookie cutter. In this case, we have a cookie cutter called Q. Q-U-E-U-E, the name of the record, is the name of a cookie cutter. Every time you say, oh, I think I can use another Q type of record, you take out the cookie cutter called Q, and then you stamp on the columns, and now you have another Q. So that means using the same record Q definition, you can stamp out as many objects or as many cookies as you want that have exactly the same structure. Everything you stamp out using the cookie cutter called Q, they will all, each one will have a head index, each one has a size, each one has items as an array of 4 items. Okay? And each one will take up 6 columns too, okay? Because each one will have exactly the same structure as this here, okay? But it is important to differentiate between a cookie cutter and the cookie that you cut out using the cookie cutter. Because does the cookie cutter itself take up any space, take up any columns in this code? No, the cookie cutter does not take up any space. If I did not have line 7 and line 8 and instead I have some other lines, I would not be using the cookie cutter. The cookie cutter would not have used up any space. The columns from column C to column H, they are consumed by the cookie, not the cookie cutter. The cookie cutter is nothing more than a template so that you can create things like variables of a particular structure. Okay? And for the same reason, just remember, you cannot eat cookie cutters. Okay? And you can eat cookies. Cookies are variables, and cookie cutters are the names of the records. Okay? So if you remember the analogies, you will have the basic understanding to move on to an object-oriented programming class, because they will just change the names. A class is a cookie cutter. An object is a cookie. Okay? So you will encounter those names later on, but if you remember the analogy of cookie and cookie cutter, you can extend this analogy, and it will make it easier to understand the object-oriented programming terms when you move on to that class. So that's it for today. I know I have talked about enough about food, so you guys need to go home and get some. Don't forget the homework assignment.